hang up and try again.
Today we're going to talk about dollar. It's a case study for object orientation. So we will create an object called dollar with properties, characteristics called the fields. We're also going to discuss the constructors and methods that makes this class dollar unique. Again, this is an American dollar. As you can probably see, I got this picture from the internet, of course. But let us just take some time to distinguish what this dollar is. So when we observe this dollar bill, we observe that there is a face, and depending on the face, you can have a denomination. We have color, we have a shape. I know it's a rectangle, but there is some shape on inside of the figures. There's a denomination. Remember that the dollar bills can have a 1, a 2, a 5, a 10, a 20, a 50, and a 100. So we have a couple of those denominations. We also have a number, a unique number. It's called the serial number. And that number basically is provided there. As you can see there, here we have L111809116 and then the letter G. So that's the very unique number that you provide to the dollar bill when it was fabricated. We also have some verification seals. I don't think you can observe here, but usually the regular dollars, they have a verification seal just to make sure they're original. We have the year where it was published. So here are the actual attributes that we describe. For simplicity purposes, we're just going to select a few of them. The face, denomination, the serial number, and the year will be enough to demonstrate this in Java. So the way we're going to represent this dollar representation, this fields, for example, the face is a string. Why? Because if you notice, the face, we have Washington or Jefferson, Lincoln, Hamilton, Jackson's, Grant, and Franklin. I decided to call it face because not all of them, they're presidents. So you might think that they're all presidents. Some of them, they were not. The nomination depends on the face, or depends on the nomination, depends how you want to see it. You will have the face or the denomination. You have 1, 2, 5, 10, 20, 50, 100, and you have 1,000. But 1,000 I don't think is for commercial purposes. And that will actually take place in code as an integer. The serial number is a string because it's a combination between alphanumeric. You have numbers and you have letters there. So you will have this kind of a mixture, a letter at the beginning, a letter at the end, and numbers in between. And finally, you have a year. It's a whole number. For example, if a dollar is published in 2020 or 2021, it should be denoted as an integer, as a whole number. We're gonna follow this UML as a design for our object dollar. And this, as you can see here, at the very top is the name of the class that you're going to create. The next square determines the fields. The minus signs means that there are private fields. No longer in objects, we use public for the field. We use the minus to determine it's a private field. And then here you have the denomination, face, serial, and year, followed by the data type, int, string, and an int. The next part are the methods or the actual constructors. The very first three, we provide a flexibility of dollar. We have dollar open close, that's called the default constructor, followed by two customized constructors. The customized constructor number one is the one takes a parameter for each of the fields that you have, int, string, and int. Those will initialize the fields that you can see in the first square. But we also have a variation of that customized constructor, the one that takes only 3 parameters, int, string, and int. We're missing one field, the one from the face. But based on the denomination, for example, the int, we can determine the face internally. And then we have the accessors, the ones that says get. Every time that starts with get, those are the accessors or the getters. Notice that they don't take any parameters, but instead they return a specific data type in string, string, and base on the accessor that you're creating. We also have the setters, set denomination, set phase, set serial, set year, and they do take parameters in order to set the old state of the data type with a specific argument value. Notice that all of them, they're void, they're return void. So that is something that you need to recognize as well. And then we have the print info. It's a void method that will basically print all the information. This is going to be substituted by something called toString. We're going to transform print info into the toString later on. And then we have get age, which basically calculates internally the age of this dollar bill based on the year that it was published. So let's go ahead and code this UML and demonstrate by creating a couple of instances. The first thing we have to do is to define our fields. As we already know, there's 4 fields that we're interested to do. Those 4 fields are denomination, phase, serial, and year. Those are the data types that we have to have for each of those fields. Now, this is the time where we need to take care of these fields. It's very important, ladies and gentlemen, that the integrity of the fields must be intact. There's a couple of security issues nowadays, and if you don't design your fields correctly with the proper encapsulation type, you might find some kind of problems later on. That's where always the fields must be private. Private is the encapsulation data type that allows us to basically protect the fields of each class, which means that only the members of the class dollar can access the fields, denomination, phase, serial, and year. Everything that is outside of the class dollar will not be accessed. This is the protection, this is the integrity. For that, we can access those fields only if we provide the getters or the accessors. But it's very important, as a matter of fact, it's critical that all the fields of an object must be private. Unless the UML describes differently or otherwise, then you should keep always them private. The next thing that we will provide are the constructors. The constructors are in charge to initialize the fields. Notice that the fields here, we only declare them, but we don't have any value. We know it's an int and a string and a string and an int, but they don't have values. That is the case. That is responsible the constructor. It's always a good idea to have the default constructor, or what we call the non-argument constructor. The non-argument constructor basically helps us to initialize the fields to the default value. In case you forgot to have any kind of instantiation with values, you provide them using the default values. For example, denomination is an integer, and the default value for an integer is 0. Similar fashion is phase. Phase is a string, and string, they're a little bit different. Usually you can initialize it with the empty string or with a special value called null. Null is the default value for any object that you deal in Java. So let us go ahead and initialize these fields from this class to the default value. Notice that I'm repeating the word this, and it's because in this class, there is a denomination, as you can see here, and it will have the value of 0. In this class, there is a phase, and it will get the value of null. In this class, there is a serial, and it will get the value of null. And in this class, there is a year, and it will get the value of 0. The keyword this represents as a reference that in this class, there is something in the terms of the scope called denomination, phase, year, and serial that will get these values as a default. The word this is very useful in object orientation programming to refer to some methods, constructors, fields inside of this class. The next thing is to create our customized constructor. Notice that this time we will provide the 4 fields as parameters. So we will initialize this denomination. We'll get the denomination provided as a parameter. In this class, there is a phase, and it will be initialized by the phase provided as a parameter. In this class, there is a serial, and it will be initialized by the serial provided as a parameter. And in this class, there is a year, and it will be provided by the year provided as a parameter. In the left-hand side of the equal signs, we're referring to everything that is in this class, the fields. Everything to the right-hand side of the equal signs, you're calling about the parameters, the argument that you pass in there. Notice it's the same name, but notice that here there is a different color to determine the ones that belongs to this class versus the ones that are parameters. The next constructor is customized constructor number 2. It's very similar to the one that we're providing in customized constructor number 1. The only difference is that here we're gonna have only one parameter missing, the one from the face. Here what we can do is denomination, serial, and phase are initialized based on the actual parameters values. What happens to the phase? So the purpose of the constructors are to initialize all the fields. So we must initialize also the phase. But notice this is not given to us, Professor. I know, but they're giving us the denomination. And we can make a mechanism in order to initialize the phase based on the denomination. For example, we can create a switch where we have denomination as the entry part. And we can have the case that is 1. And if that is the case, then we know that this phase will be Washington. In case we have case 2 is Jefferson. In case 5, Lincoln. Case 10 is Hamilton. 20 is Jackson. 50 is Grant. And 100 is Franklin. So we have here a constructor that based on the denomination, we will create a switch case in order to initialize the phase. You can also make this with an if statement if you want to. I just thought it was a good exercise to practice our switch case again. So let me just tell you here real quick, we have 3 different constructors. One is the default constructor, which has no argument, also known as the non-args constructor. Customized constructor 1 has 4 fields, and customized constructor 2 has 3 fields. Notice that they all start with $. It's very important that the constructor has the same name of the class. As you can see here, if I highlight $, it will be highlight everything that relates with $. So that is a key point. If you don't have a customized constructor or a default constructor with the same name of the class, this will not work. Java is smart enough to recognize when you're dealing with constructor later on when you create instances. So here, notice that we don't have duplication because the headers are different. This has no parameters. This one has 4, and this one has 3. And Java allows you to do that. This is called method overloading. Method overloading allows you to have flexibility in the actual definition of the method. You can use different methods with different parameters just to provide the flexibility to the computer programmer. We have seen instances of method overloading in the past with other classes. The next step is that for every of these fields that we provide, we will create accessors and mutators. In other words, getters and setters. I just provide the information, the Java documentation for each of those getters. The getters, remember that they start with the command public, encapsulation public. It will return as is specified there in the tag, the data type that is specified there. In this case will be int. The name is get denomination and doesn't take any parameters. It will return this denomination. In similar fashion, we're going to do the same thing for the rest of the accessors. Accessors allows you to retrieve information, and it makes sense because if you remember the method, the fields that we have are private, and some people might require to access them. We don't want them to touch them, so we can just provide accessors as a way to access information directly through the method. The next type of methods are called the setters. The difference between setters and getters is that setters, they do have parameters, and this represents the new value for the field that you're going to change. Doesn't have any return type. As a matter of fact, they're void. So the method starts with public and they're void, followed by the word set, and then the field that you want to change. Provide the parameters, and the only thing you have to do is to change the state of the nomination, in this case, this denomination, to the new one that you're providing as a parameter. The denomination I'm highlighting right now is the one that corresponds to the parameter. And this denomination, the left-hand side of the equal signs, corresponds to the one that we have in the field denomination. As you can see, we've been consistent with the way we actually initialize our fields in the entire constructors, accessors, and now on the setters. I'm going to do the same thing for the rest. Now we have getters and setters. Notice that we're creating the blueprint. Right now, there's not too much value. As a matter of fact, we haven't really initialized anything. We're just creating the blueprint, the cookie cutter, in order to make this program workable later on. Later on, we're going to create objects that relates to this object dollar and help us to create operations and whatnot. There's two more methods that we need to create. Print info will only print. It doesn't really take any parameters either. And the only thing that we're going to do is to print the information in a format way. We can put here the dollar sign combined with the denomination. And we can put here just maybe the face, the serial number, and the year. We also have another method that we would like to generate, and this is called get age. This method will calculate the age on this dollar. It will not take any parameter, but it will return an integer representing the number of years this dollar has. It's a public method. Integer is the return type. Get age is the name. Doesn't take any parameters. And the only thing that we're doing here is to subtract the current year minus the age. We're in 2021 minus the year that was created. To be consistent, we should put this year here. Similar fashion, I forgot to mention that. We should put this year everywhere. This works without the this, but we want to be consistent with our programming style. I will come back to print info in a little bit, because this is a good method to represent information. Only problem is that Java provides us something similar. It's called the toString. We're going to talk about that in a little bit. The next thing we have to do is to create the main. But the main doesn't really go under dollar. The main goes in a different class. It's outside of the cookie cutter. So we're going to create a new class. And we're going to call Department of Treasury because that's where we create the dollars, just as an analogy of our objects, dollar. And here's when you have the main. This class, Department of Treasury, must be saved, ladies and gentlemen, in the same directory when you have dollar. If you don't have it in the same directory, then we're going to have a problem later on. So it's important to both files, Department of Treasury and dollar, they're in the same working directory. Here's where you're going to create the instances of the object. For example, what I just did on line 3 is to create the instance of dollar using the default constructor. We can prove this by using print info. Notice that D1 is the object and print info is inside of the object D1. So line 3, ladies and gentlemen, is called an instance of dollar. And line 4, we're calling the method from dollar D1. If we save compile this program, we will get a funky way to actually see the default value of here. We have $0, null representing the face, and then we have null representing the serial number, and the year that we create is 0. So obviously here we using the default value of the object dollar. But okay, that's a good try. At least it works. So let's go back to the code. We're gonna create another instance of dollar. We're gonna create D2. And this time we're going to use the customized constructor number 1, the one that takes a denomination, a face, a serial number, and some year, for example, 1999. And we're going to do d2.printinfo as well. We're going to create another instance. And this time we're going to use the second customized constructor. Let's have here a 5. Let's just generate some kind of another number. Okay, I'm just using my keyboard here. I'm just making up those numbers. And then let's use maybe some year, I don't know, maybe some older. Let's use another year. And we use D3 that as you can see here, when I press D3, this code give us the options that you want to use here. Like here is all the methods that you can use. I don't know if you can see here. Equals is something that we inherited. Later on, I'll talk about that thing. But here is, for example, get age, get class, get denomination, face, serial. So all this information is provided to you. In the right-hand side, look how nice is this. It will give us the description that we wrote in the Java doc. As you can see, as I hover under the get age, it tells me this method will calculate the age of this dollar. It returns an integer representing the number of years. Get denomination, an integer represents the denomination of this year. So Java is smart enough to bring all the Java documentation that we create in the other class. You can also have print info. For example, if I go here, I forgot to put the Java doc, but it will print the information. Let's save, compile, and run this program. And let's see what happened. Let's pay attention to what is happening here. So the first line, which is the one from the $0, is the customized constructor one. Okay, that's fine. We knew that. The second one is number one, which is the $1. Washington is the face. This is the serial number, and this is the year it was created. We also have the $5 bills by Lincoln. And notice that we didn't provide Lincoln, but we using the actual customized constructor number 2 in order to generate that for us. It respects the serial number and the year. So it's working. It's working very good. Let's go back to the code. So you might think, Professor, how about if we just print the D1, D2, and D3 instead of just using the print info? You're probably tempted to do this. So if you print the object itself, it's going to be different. I want you to pay attention. Let's go back and save compile this program and then run it. Notice this thing. We have that funky thing that we saw last time on arrays. This is a hexadecimal address location where the dollar is located. Remember that? We already discussed this, and this is where we store information in memory, the instance of the object that is located in those particular memory locations. They're different because they're different objects located in different locations. This is called the toString. And if you remember, the toString is only the textual representation of the object that we're trying to print. That's why we use print info. But this can be changed. This can be changed by overriding on the class dollar when we create a method called toString. The method toString is a method that we inherit from our ancestor. I'm going to talk about in a little bit inheritance. So the toString basically gives us the textual representation of our object. Very similar for what we did here in print info. We can do that, but in terms of string. Ladies and gentlemen, the toString must follow this thing. It's a return type is a string and doesn't take any parameters. Has to be written the same, toString, capital S. And we will return a string like this. And we can make it even nicer by saying this dollar is, and then we can call get age years old. Now, notice that I wrote this. I overwrote this under $.java. And if I go to the Department of Treasury, I haven't changed anything here. However, if I compile and run this program again, notice how that's going to change. So instead of having those funky values of dollar at the hexadecimal address location, now we have something more elaborate. $0, null, null, this dollar is 2020 years old, of course, because 2021 minus 0 is 2021. But something more realistic is this dollar, right? The Washington one has this serial number, and this dollar is 22 years old, similar as with Lincoln, and this is 33 years old. You see how that changed? That is because we're incorporating the toString, and the toString will give us the textual representation of this object, which is inheritance.